Okay, let's work the last one from the 2023 AP Calculus exam. FRQs that were released the other day. Working this one cold, have not looked at it. No calculator. Here's number 6, the last one. All the others are posted on my YouTube channel. So number 6, 2023, AP Cal AB, FRQs. So for number 6, we have the curve 6xy plus 2 equals 2 plus y cubed. Show that dy dx equals 2y over y squared minus 2x. So let's take the derivative of both sides, and we're going to get 6 times x y prime plus y, taking the derivative with respect to x, dy dx. So it's just y times 1 plus, equals, derivative of constant is 0. So 3y squared y prime. Of course, y prime is dy dx. Distribute, get 6xy prime plus y equals 3y squared y prime. I'm going to move to 6xy prime, get y equals 3y squared y prime minus 6xy prime. I'm going to factor out a y prime. And we're going to get y over 3y squared minus 6x equals y prime, which is dy dx. So we multiplied both sides by 2. We divide both sides by 3. Oh, I didn't need a 6 here. There we go. Simple algebra mistake, right? Now, multiply top and bottom by 1/3. Like we always say, it's the algebra that kills you. 2y over y squared minus 2x equals dy dx. So that's part A. And that should suffice. Part B, find the coordinates of a point on the curve at which the line tangent to the curve is horizontal. So for this one, dy dx has to be 0. If dy dx is 0, then y must be 0. Because 2 times 0 over 0 minus 2x equals 0. Therefore, 6x times 0 plus 2 that's not going to work. Let's find the little curve solution. If I factor out the 0, factor out the y. Let's go back up here and let's find solutions. If we have 2 equals 6xy minus y cubed, then 2 would equal y times 6x minus y squared. If y is 0, that won't work. this implies that 6x times 0, that's what we need to show, equals 2 plus 0, which implies 0 equals 2. This is impossible. Therefore, there is no point on the curve with a horizontal tangent. Spent a little too much time trying to show something that doesn't exist there, because I should have gone back to the question as soon as I realized that I wasn't getting an answer I expected. Okay, but we got there. Find the coordinates of a point on the curve at which the line tangent to the curve is vertical. Explain why no such point exists. So in this case, the denominator would have to equal 0. So for dy dx, and the numerator would not equal 0, or the multiplicity of the 0 would be more greater than in the numerator, or in the denominator than the numerator. Okay, so in this case, y squared minus 2x would have to equal 0, which would mean x is equal to, let's go 2x equal to y squared, x equal to y squared over 2. So if we go back to our original function, or not our function, our original curve, we would have 6 times y squared over 2 times y would equal 2 plus y squared, or y cubed. That would be 6, well, let's go 6 over half. It's going to be 3y cubed equals 2 plus y cubed, or 2y cubed equals 2. So y cubed equals 1, where y equals 1. Y equals 1 would imply, let's see, go back to the original function, original graph. Oh, here we go. That would mean that x equals 1/2. So the point 1/2, 1. If I plugged in 1 and 1/2, that would definitely give us the vertical tangent. It would be undefined. So there's a vertical tangent. At the point 1/2, 1. Now D, particle moving along the curve at the instant when the particle, at the instant when the particle is at the point 1/2, -2, its horizontal position is increasing at the rate of dx dt equals 2/3 unit per second. What is the value of dy dt? The rate of change in the particle's vertical position at that instant. So dy dx equals dy dt over dx dt, and we are given dx dt is 2/3, and we're given the value of the point. So dy dt dx dt equals 2 times y over y squared minus 2x. So that means that dy dt equals, and now we're going to go ahead and plug in, this is the point 1/2, -2. So I'm going to go ahead and put the 2/3 in for the dx dt and multiply that by Negative 2 is y, so it's going to be 2 times negative 2 over y squared is going to be 4 minus 2 times 1/2 is going to be minus 1, which is going to be negative 4 times 2 is negative 8 over, this is going to be 3 times 3, 9, and this is going to be in units per second. Negative 8/9 unit per second. So the rate of change of the particle's vertical position at the point (1/2 negative 2) is negative 8/9 units per second. And that should do it for question number 6.